The benefits of the bridging method. The bridging method of project delivery for design and construction programs is a hybrid of the traditional design, bid, build, and design build methods. It retains the best features of each from the owner's standpoint and eliminates those aspects of both methods which often cause problems for the owner. The method has significant advantages to owners of major construction projects, including projects of all types and levels of complexity. The main advantages are reduced exposure to construction risks and better buys for the owner for a fully equivalent end product. Through the use of bridging, the owner is able to obtain a highly enforceable contract price in about half the time and about half the at-risk upfront cost as compared to any other method. Bridging is the only method that gives the owner a truly enforceable contract price before final construction documents are complete. Bridging, properly used, will also greatly reduce the owner's exposure to contractor-initiated change orders and claims. It will also result in a clear, single responsibility for more quickly correcting any flaws in the design or construction that are discovered after completion and occupancy. The use of bridging does not result in any loss of opportunity for design creativity, nor loss of control over the quality of construction. The use of bridging by knowledgeable owners is growing, and growing for a wide range of building types and sizes in locations throughout the United States and abroad. Review of design, bid, build, and design build. To fully understand bridging, let's first review the traditional method, often referred to as design, bid, build. To review the traditional method, we will use this simple graphic of the phases of design and construction. Before the sequence starts, to the left of the bar chart, we assume that the program of requirements and the site have been decided upon, and that an architect and the architect's consulting engineers have been selected. Later, we may refer to those design consultants as either the architect or the AE. In the chart at left, SD stands for the architect's schematic design services, including the owner's review and approval. On a large or complex project, there will probably have been a number of interim design reviews by the owner during this phase of design. In the next phase, to the right, DD stands for the architect's design development services, i.e., the fuller development of the schematic design that has been approved by the owner. As in the SDs, there will probably be a number of interim design reviews. The owner usually signs off on the design to a substantial degree by the end of this phase. In both the SD and DD phases, there will have been mechanical, electrical, plumbing, structural, civil, and specialty engineering consultation with the architect by the architect's consulting engineers. Also, in the DD phase, at least, a number of drawings and proposed specifications will have been prepared for the various engineered systems of the project. Next, in the CD phase, the AE prepares the final and detailed working drawings and specifications, properly referred to as the contract documents. These documents will be the basis of bids or negotiations for the construction contract price and, along with shop drawings prepared by various fabricators during construction, will be used for the actual construction of the project. The dollar sign indicates the bidding or pricing for the construction and all contract conditions. The actual award by the owner of the construction contract to the successful general contractor would also occur at the conclusion of this phase. And finally, at right, is the construction phase, during which the AE and/or a construction administrator, sometimes referred to as a construction manager, will observe the work in progress on behalf of the owner and administer the contract between the owner and the contractor on behalf of the owner. This administration of the contract will include the approval of progress and final payment requests by the AE and/or CM. There are many advantages for the owner in the traditional design, bid, build method. First, it is a logical and orderly process, well understood throughout the industry. Second, it easily meets all procurement procedure requirements. Third, there is the direct professional relationship between the architect, including the architect's consulting engineers, and the client, that is, the owner and sometimes the user or users of the facility. And fourth, a contract price can be set by either competitive bidding or negotiation prior to the owner committing to the construction phase. However, over the years of its use, a number of flaws have developed or come to light in the traditional design bid build method. There are 5 serious flaws. 1. It takes too long and costs too much to get to the point of the owner being protected with a total construction contract price that can be reasonably expected to hold up within a few percentage points throughout the construction phase to completion and occupancy. 2. Virtually all construction contracts are predicated on the drawings and specifications being free of errors and omissions, yet that is humanly impossible. 3. The method assumes that architects and engineers have the best knowledge of construction technology and cost-effective construction methods, yet that is not true. Probably the best knowledge of construction technology and cost-effective construction methods lie with specialty subcontractors and building product manufacturers, who are substantially left out of the design process in the traditional design bid-build method. 4. After completion, there can be a frustrating and costly situation for the owner with no clear single responsibility for the correction of post-construction problems. 5. In simple terms, the owner is caught in the middle in a traditional design bid build contract. Now, let's look at another frequently used project delivery method, design build. This chart shows the 2 most common general approaches to design build. In both cases, the basic difference between design build and design bid build is that the owner has one contract with a party that does both the design and construction. Typically, that will be a construction contractor who has the project architect and engineers as a subcontractor or construction company which has architects and engineers as staff of its company. In the version illustrated at the top, the owner, probably with the help of a consultant, prepares a request for proposal incorporating information about the site and the owner's program of requirements and possibly some design criteria. The owner then receives price proposals for both the design and construction, with the proposal being accompanied by and based on a preliminary design, often the equivalent of schematic design. Thus, the owner can look at price and preliminary design as well as the qualifications of the design-build team in selecting the design-build contractor for the project. The version illustrated below the one we have just reviewed is based on the owner selecting the design-build team based on qualifications only. Then all design and costing is done on a single source basis after the owner and the design-build contractor have an agreement. Many owner organizations have used design-build with good success. 2 major advantages of design-build are: there is a good potential for better integration of construction know-how into the design process. The other is that there is a single responsibility for all aspects of design and construction, overcoming the caught-in-the-middle problem for the owner in the design-bid-build method. However, there are some serious disadvantages inherent in the design-build process. A major one is the conflict of interest between the architect and engineers and the owner because the AE is in the employ of the construction contractor. Another is the early loss of leverage on price and performance requirements by the owner. And thirdly, in design-build, it is difficult, virtually impossible, to have apples-for-apples competition on price and performance. Yet many owners, particularly private sector manufacturers and chain retailers, have had good success with the design-build method. How bridging works. As mentioned in the introduction, the bridging method is a hybrid of the traditional design-bid-build method and the design-build method. It retains the best features of both and eliminates those aspects of both that often cause problems for owners. Looking at the chart illustrating the bridging method, the owner, possibly with assistance of a program manager, selects an architectural and engineering design team who will be referred to under bridging as the owner's design consultant or the bridging architect, referred to by some as the design architect. The owner's design consultant will go through schematic design in the same way that the owner's AE does under design bid build. This is seen as the SD phase at left in the chart. As in the case of design bid build, if the project is large or complex, there will probably have been a number of design reviews and approvals by the owner during this phase, just as in the design bid build method. Then, at the point in the design process in which the architect and the architect's consulting engineers would have gone through the design development phase, there is a design phase of at least the same level of effort as design development, but is substantially different in many ways from DDs. The documents produced during this phase are referred to as the bridging contract documents, BCDs, or the bridging bid documents. We will come back to those differences in a few minutes, but suffice to say that the architectural effort is greater during this phase than in a typical DD phase. However, the engineering work in this phase, while sufficiently extensive in terms of consultation with the design architects and in terms of performance specifications, results in relatively few drawings and prescriptive specifications. In other words, the architectural design is set in significant detail by the end of this phase, but the engineering work has been developed in consultation with the architect to represent a set of protective design criteria for engineered systems. Based on the bridging contract documents, fixed price bids may be received for the remainder of the design, the remaining design mainly being the engineering design and the coordination between the engineered systems and the architectural elements of the project, along with the full construction itself. As you will see as we go into more detail on bridging, prices based on these documents are highly enforceable, at least as enforceable as the prices received based on construction documents in the design bid build method. And this price will be far more enforceable than a so-called guaranteed maximum price based on incomplete design documents under the design bid build, design build, CM, or CM at risk methods. Upon award of the design build form of contract, the contractor is only authorized to go through the preparation of the final construction documents. In bridging, CD refers to construction documents, not contract documents, a significant difference as you will see as we further develop an understanding of how bridging works. The contractor will have different architects and engineers who will either be a sub to the contractor or part of the contractor's organization. The contractor's AE will prepare the construction documents. The contract between the owner and the contractor will require that these documents are in full compliance with the bridging contract documents. This compliance will usually be determined by a detailed review of the CDs by the owner's design consultant. At the end of the CD phase, the owner has the right to terminate the contract without cause and for the convenience of the owner, thus providing the owner with good leverage for the proper preparation of the construction documents by the contractor's AE. The CDs must be complete and in full compliance with the bridging contract documents. More later about the bridging contract documents. The final phase is the construction with the design build form of contract being administered by the owner's design consultant and or CM or program manager in a very similar fashion to the administration of the construction contract under the design bid build method. Now, let's pull up a chart of the design bid build method compared with bridging. The design bid build method is seen at the top. The bridging method is seen at the bottom. At top, under design bid build, there are the three parties of the contractor, the owner, and the owner's AE, and possibly a fourth, the owner's program manager working with the owner's AE. At the bottom, under bridging, there are still three basic parties, the contractor, the owner, and the ODC, and possibly a fourth, the owner's program manager working with the ODC. The other AE is the contractor's AE, who is a sub to the contractor and is the architect and engineer of record. Note that in both cases, the owner's architect under the design bid build and the ODC under bridging usually provide services to the owner throughout the design and construction phases of the project. In the case of design bid build, the owner's architect serves the owner through all phases of design, the bidding and award phase, and the administration of the construction contract, including construction observation and the approval of progress and final payment requests. In the case of bridging, the ODC serves the owner through both design phases of the pre-award period, through the bidding and award phase, and through the administration of the design-build contract. As part of the administration of the design-build form of contract, the ODC would determine that the construction documents prepared by the contractor's AE are in compliance with the contract documents prepared by the ODC. The ODC services would also normally include construction observation and approval of progress and final payment requests. And, of course, if there is a construction program manager, that consultant will represent the owner through all phases in both cases. Bridging contract documents. Let's now review the contract documents of the agreement between owner and contractor in a bridging method project. They are the instructions to bidders, the form of proposal, the form of agreement between the owner and the contractor, which will be a design-build form of agreement with modifications, the form of performance and payment bond if required by the owner's organization, the design guide illustrations, referred to as DGIs for short. These are the drawings prepared by the ODC, being mostly rather advanced architectural drawings. The owner's minimum requirements are referred to as the OMR for short. The OMR is a specification-like manual of 16 sections consisting of mostly performance specifications, but with some prescriptive specifications as required to protect the owner and the design. The construction documents, after being prepared by the contractor's AE and found by the owner's design consultant to be in compliance with the contract documents, in particular the DGIs and the OMR. These construction documents will then supplement, but not supplant, the contract documents. Consequently, the owner will be entitled to receive everything that is called for in either the contract documents or the construction documents, and, if a conflict in the documents is found, the original contract documents would prevail. Now let's go into more detail as to how the bridging contract documents are different from traditional design development documents. The owner's design consultant, whom we will refer to as the ODC, and the ODC's consulting engineers will prepare the bridging contract documents. As the note indicates, this chart illustrates the typical level of design and preparation of drawings and specifications that are exhibits in the request for proposal, which are also the contract documents of the agreement between the owner and the contractor. On the chart, in the vertical dotted line at the far right, you will see the note 100% CDs. This refers to the full and complete design services by architects and engineers, including the traditional preparation of the contract documents under the traditional design bid build method. Now note the arrow pointing to the vertical dotted line in about the middle of the chart indicating 46.5%. In the American Institute of Architects standard form of agreement between owner and architect, through the many iterations of that contract form, the schematic design services constitute 15% of the total services. The design development services constitute an additional 20% of all services. The preparation of the traditional contract documents constitutes an additional 40% of all the AE services. The remainder of the architect services are for bid and award advice, along with basic construction administration services. Thus, all design services constitute 75% of the architect's total services under the traditional design bid build method. With schematic design and design development services constituting a total of 35% of all of the architect's services, SDs and DDs constitute 46.5% of the architect's full design services. Thus, 46.5% of the architect's traditional design services, almost half of the design work, is that part of design services made up of the traditional schematic design and the design development services. Now, let's look at the basic concept of bridging contract documents. Two important aspects of the bridging contract documents illustrated by this chart are: 1. Bridging contract documents are quite a bit different from traditional design development documents. 2. There is more work done in terms of setting the design in the architectural elements of most projects than in the engineering elements. The basic idea is that everything that needs to be designed or tied down for the owner to get what is needed and expected in terms of the end product should be designed or otherwise tied down in the bridging contract documents. However, as much latitude as is feasible and prudent should be left to the contractor, i.e., design-build team. This is a judgment call mostly for the ODC and will vary from project to project. This chart is an illustration of a typical set of bridging contract documents. Let's look at a couple of details. In the second horizontal bar down from the top of the chart, you see that almost no design work or prescriptive specifications are usually required for the foundations. In most cases, code compliance, as the basis of the performance specifications, will be the extent of the needed criteria for the foundations. But then look down to just below the middle of the chart at the horizontal bar for finished hardware. In most projects, the finished hardware must be rather completely specified and scheduled in the bridging contract documents in order to protect the owner and the design. Look at the two horizontal bars on plumbing. Most of the plumbing system can usually be covered with code compliance requirements, except possibly for specifying the type of piping material, such as copper versus plastic and cast iron versus plastic, plus any special requirements such as water filters. However, the actual fixtures are all fully selected and specified by manufacturers, model numbers, fittings, and so on, as well as floor drains and the like. The HVAC horizontal bars indicate that the type of system is probably selected with advice from the ODC's mechanical engineers, along with specs for the controls. The ODC's mechanical engineer will also have advised the ODC on floor space and other spaces that should be allowed for the system's various elements. The ODC's mechanical engineer will usually want to make extensive use of performance specs for the HVAC system. However, since supply and return grills are often very much a part of the architectural design and detailing of the building's interior, they are typically selected and specified in detail. And, as you will see from the bars on the various architectural elements of the project, the ODC's design work and preparation of drawings and specifications goes beyond the normal level of DDs. An engineering consultation for the ODC will need to be extensive enough for the ODC to know that the architectural design allows for and accommodates all of the engineered systems. If in doubt on a particular aspect, the ODC and its consulting engineers should err on the side of detail and prescription. However, the reason they should be thoughtful in these decisions is that the more they tie down, the higher the construction contract price will be, and the less benefits there will be from value engineering that can and should be a part of the design-build process. By the way, bridging automatically builds in the most dynamic form of value engineering in the proposal process, with the owner getting 100% of the savings built into the fixed price. Benefits to owner. Let's review then the major benefits to the owner of the bridging method. 1. The owner gets a highly enforceable contract price in about half the time and at about half the front-end cost as in the traditional method. And, actually, it is the only system that gives the owner a truly fixed price and is the only system other than design bid build and design build that fixes that price prior to the start of construction. This means the bridging price is a far more valid price than a price on either a design bid build contract or a design build contract. 2. The overall design and construction cost is lower for a fully equal end product. 3. The owner's exposure to unexpected change orders and claims is greatly reduced. Bridging provides a huge gain in this area for most owners. This reduction in claim exposure is becoming more and more important because the architect's traditional responsibility to coordinate the construction documents has been made more difficult due to more sophisticated engineered systems and their interrelationship with the architectural elements. This coordination is becoming increasingly difficult for the architect, reaching the point of being close to impossible in the preparation of truly complete and error-free contract documents. If nothing else, the bridging method creates a single-point responsibility for this intricate coordination. This alone makes the method a great deal for the owner, keeping in mind how much financial damage the owner can suffer from less than perfect coordination of these systems in traditional contract documents. However, it is not suggested that the many other advantages of bridging be overlooked. 4. There is a clear single responsibility for fixing post-construction problems, usually at no cost to the owner. In addition, we have seen in actual completed projects that construction times are shorter with bridging. And, again, the benefits are realized without any loss of opportunity in creativity and design or loss of control over the quality of construction. The bridging method was first developed by George Heery, Chairman and CEO of Brookwood Program Management of Atlanta, seen here with a model of the Wakefield, a high-end cooperative apartment project in Atlanta's Buckhead area, designed and built under the bridging method. Other professionals, such as Mr. Heery's eldest son, architect and developer Shepard Heery, Mr. Heery's friends Alvin First of Atlanta and Chuck Thompson, former chairman and CEO of 3DI, along with colleagues Brent Smith, Bob Bunker, and Bill Ray, have contributed to the further development of the method. Mr. Heery's first use of what would eventually become the bridging method was in 1976 for Rich's Department Store's service center in Stone Mountain, Georgia. This was followed by the use by Mr. Heery of a very similar version for the Federated Department Store's corporate headquarters high-rise office building in Cincinnati in 1977. He first proposed it as a definitive method of project delivery in the early 1980s. The name bridging was suggested in 1989 by Shepard Heery and came from the idea that the bridging method bridges the owner into a more enforceable price sooner and with lower costs at risk, bridges practical construction know-how into the design process without the owner giving up leverage, and bridges over for the owner many of the risks in a construction program.